Okay, so let's look at a video where we'll do some practice problems with the Catalan numbers. Before we dive in, let me remind you from the previous video, the formula for the Catalan numbers we got was b sub n equals 2n choose n minus 2n choose n minus 1. If you're wondering why, go back to the previous video. As with all of these videos, I'll present the problem, give you some time to pause, solve the problem, present the numerical solution, and then explain the solution through. If you understand and can move on, there will be links to the various problems in the description down below. Example 1. Calculate each of the following: b1, b3, and b4. Pause the video, solve this. Alright. b1 is 1, b3 is 5, and b4 is 14. And here's why. Following the formula, b1 will have 2n, choose n, minus 2n, choose n minus 1. And this is probably the only one I'll work all the way out by hand. Some of the smaller numbers are fine to work out by hand, but when you get to large numbers, it's just a pain. So 2 choose 1 is going to be 2 factorial over 2 minus 1, 1 factorial, times 1 factorial. 2 choose 0 is 2 factorial over 2 minus 0 factorial, times 0 factorial. In here, 2 factorial is 2, 1 factorial is 1, so we get 2 over 1, 2. 2 factorial is 2, 2 factorial is 2, 0 factorial is 1. If you're not sure on why, I made a video about that about a week ago. So 2 divided by 2 is 1, and 2 minus 1 is 1. B3, same idea, 2n, choose n, minus 2n, choose n minus 1. And when I work this all the way out, I'll get 5. And same thing for b4. 2n, choose n, minus 2n, choose n minus 1. And when I work all of that out, I'll end up getting 14. Example 2. You are going on a hat and hat box buying spree. You're going to buy 10 hats and 10 hat boxes in any order, as long as you always have enough hat boxes for all of your hats. In how many different orders can you buy hats and hat boxes? Pause the video. Okay, so in here, there are 16,796 possible ways, because it'd be crazy to buy more hats than boxes. Where would you keep all your hats then? And so when I go through this for the Catalan numbers, I will always need to have at least as many boxes as I have hats. And that means that this can be calculated by B10, which is going to be 2n, choose n, minus 2n, choose n minus 1. And working this out, I'll get the 16,796. Example 3. Consider the product A times B times C times D times E. In how many orders can you multiply these numbers together using only the associative property of multiplication, no commutative property allowed? So there are 14 ways for this to happen. And what's happening is this. I need to insert parentheses. There are 4 operations, which means I will need exactly 4 open parentheses and 4 closed parentheses in some order around this. There's also the restriction that I cannot close a parentheses before an open parentheses. That's mathematically not valid. And I need to make sure that every single set of parentheses deals with a multiplication problem. So here's what happens. I'm not going to consider this like this here. Just for a case in point, if I try to say, okay, if I have this or I have this, and try to say that this is the way to arrange it, trying to do B4 based on this, there's more than one way to do these things. for instance, this could mean A times B times C times D times E, where DE is the first thing, then C, then B, then A. Or it could mean A times B times C times D times E. Sorry, I messed up. I have an extra parentheses in there. A times B times C times D times E. And just the order of the parentheses isn't good enough. But what we are going to do is we're going to consider the open parentheses. We'll have 4 open parentheses and the first 4 variables. And the rule is, in order to get them to multiply, I will always need at least as many parentheses before any variable. So I cannot start off the list with variable, because I'm going to have an A times. It's not going to have parentheses around. The parentheses are going to order what happens. I need to order all 4 of them. I need 4 sets. That would be outside of that. And so, for instance, this arrangement, open parentheses, open parentheses, open parentheses, open parentheses, the closed parentheses and the last variable are determined. So when I put A times B, that is an operation. I have to close off that parentheses. Times C, close off that parentheses. Times D, I have the operation there, close off parentheses. Times E, close off last parentheses. Or let's consider another one. What about PP, VV, P, V, P, V. So open parentheses, and in here I have variable. So I have A times, and that will be a B, and close that off. Open another one, times C, open another one, times D, and now I've run out of the list here. I have not yet done an operation in here, so I can't close off. So I have times E, close off parentheses for that, close off parentheses for that, and finally the multiplication of everything, close it all off. So I have 1, 2, 3, 4, and 1, 2, 3, 4. Open and close parentheses, and every multiplication goes to exactly 1 pair of parentheses. This multiplication to those. This multiplication goes to the large outer pair. This multiplication goes to there, and this multiplication goes to those. So this ends up being B4 for the reason of sort of open parentheses in variable order, which is equal to 8 choose 4 minus 8 choose 3, which is 14. Example 4. By inserting parentheses, how many different solutions can you obtain from 1 minus 3 minus 9 minus 27? Pause the video. Feel free to solve this. Answer is 5. Same thing as last problem, really. We just need to insert parentheses. Since there are 3 operations, then we're going to have 3 sets of open parentheses, 3 sets of closed parentheses. We're going to consider this as the parentheses and the variables, and this will determine what's going on. Each parentheses goes to 1 operation, and so let me see an example. This right here would be open parentheses, open parentheses, 1 minus 3, close parentheses, minus 9, close parentheses. So this cut off here, but now everything else is determined. I have to close that parentheses because it's the subtraction. I have to do another operation and close off those parentheses. If I had PPV, let's do PPVV, PV. So I have a parentheses. I have 1 minus 3, and I have to close off the parentheses because of an operation. I have another open parentheses and a variable, that's 9. And I don't have any operation here, so I have a minus 27. the operation between these is subtraction, and that's another way. It will actually give me a different solution because there's no way to sum up any of these to get another one. For instance, if I want to construct a 3, there's no way to get a sum of 1, 9, and 27 to get to 3. Same thing for all this. So each one is separate. Each one's going to give me a different answer, and this ends up then being B3, which is 6 choose 3 minus 6 choose 2, which is 5. Example 5. You begin on the first rung of a ladder. Every time you take a step, it will be either up one rung or down one rung. In how many ways can you take 12 steps so that you always remain on the ladder and end on the first rung? Assume that the ladder is tall enough so you will never stop or step off the top. Pause the video, feel free to solve this. Answer is 132. So this, I need to take a total of 12 steps ending up to the same thing. That means I have to take a total of 6 up steps and 6 down steps. And since I'm on the first rung, let's see, you begin on the first rung. If I take a single down step, before an up step, I will be off the ladder. So I always need to have more U's, or equal U's, as I have D's. And so this is B6. So you do 6 times 2, 12, choose 6. 12 total steps, 6 of them need to be U's. And then subtract 12, choose 6 minus 1 to take care of every case where I actually step off the ladder at the bottom, and that will give me 132. Alright, final example. You work at a pet store that has 4 cats and 4 cat carriers. You are trying to sell all the cats and all the carriers. When you sell a cat, the carrier it was kept in becomes empty. You can only sell empty carriers. In how many orders can you sell all the cats and carriers? Pause the video, solve this. And I think we're catching on. This, of course, is 14 because I have 4 cats, 4 carriers. So cat, 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 carrier, 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 carrier. I always need to sell cats before I sell carriers. I cannot sell a carrier with a cat still in it. And so this is going to be modeled by B4. 4 times 2 is 8, choose 4. Minus 4 times 2, 8, choose 4 minus 1. And that does end up giving us 14 possible orders. So like I could start off by selling 2 cats, then a carrier, then 2 cats, and then all the rest of the carriers. I could start off by selling all 4 cats and then all 4 carriers. 14 ways to make that happen. Feel free to comment with any questions, and let me know if we have any other things that you want me to cover. All right.